All right. The long title of this talk was From Data to AI Using the Machine Learning Canvas. The machine learning canvas. So initially, I mean, I'm the organizer of this conference, but I don't want to use it as a platform to speak. But I think that Ruben suggested that it would be interesting to have me present this. I'm going to make it shorter than we thought initially because we were running a little bit late. But all right, so I published this article a few months ago. So the presentation is based on that. And among the people who liked the presentation, I noticed that there were a lot of people from Brazil for some reason. So I was like, okay, that makes sense. I'll make a presentation. But yeah, I'll try to make it short. This is the machine learning canvas that I'm going to be presenting. But first things first. All right, and this is the university where I teach machine learning, and we also use the machine learning canvas as part of the course. The thing is, so it's University College London, and the campus is the one of, oops, sorry, I got that wrong. The campus is the one that we have here in this tower, which is the Canary Wharf Tower in London, if you've ever been there. It's also where we had the previous PAPIs Europe conference. And it's a School of Management, so there's different campuses across the city, but this one is the School of Management. So people are interested in how to make the connection from machine learning, which is technical, to business cases. So that's why we want to use this. And I also use the same tool for whenever I'm consulting with companies. So the other activity that I have apart from organizing conferences and teaching machine learning is being a consultant, independent consultant, helping people get started with machine learning. All right, and I want to say a couple of things about what I mean by AI. AI can mean a ton of things, but it can mean this, autonomous vehicles. I'm not going to speak about that. And this is an example from France. We've got these things running in the street. So no, actually it's in a park. So it's fairly limited, but it's deployed in the real world. It's cool. I'm not going to speak about that kind of AI. I'm not going to speak about AI that generates music or any of the fancy artistic stuff. I'm not going to speak about anything regarding vision, or maybe you could extend what I'll be speaking about to examples in the computer vision domain or computer graphics domain. But the GAN stuff, which is pretty cool, which is getting lots of media attention. Not the kind of AI that I'm going to be speaking about. I'm going to be speaking about that. So much more boring, right? And well, now we are at a stage where people seem to understand that it's important to have data. And then, they have data, they open it in Excel, and then they're like, all right, how do I get value from that? That's the big question. And apparently, one of the answers is use machine learning and deep learning, and then you'll get value from your data. I'm going to try to speak a little bit about that. There's a lot of anticipation around machine learning and deep learning, a lot of hype, as I said earlier, and that's so the hype cycle from Gartner, which sort of says that machine learning and deep learning being at the top, the hype is peaking right now. And if you look at machine learning, it's a little bit further ahead in the curve. So what's come next is disillusionment and then enlightenment and productivity. Right, yeah, that's a zoomed version. Right. And yeah, AI is also a big buzzword. So this is from an ad that we have in France for perfume, right? So it used to be actors and musicians and so on, and now artificial intelligence researcher. Crazy, So apparently you guys didn't know that before. So it's not in Brazil, but yeah, it was on TV. It was everywhere. But yeah, it seems that people are realizing that things are changing and the level of hype is going down a little bit. So there was this piece on VentureBeat about the fact that deep learning might not solve all the problems of the world, apparently. But anyways, I think that there's some really cool use cases of machine learning and deep learning in apps to make them more useful, to add smart features. So this is taken from the presentation that last year we had from Uber on Uber Eats, and they predict how long it's going to be to get your meal. So that's a regression problem, right? Predict a quantity. And then machine learning is also used to have a new take on problems that are fairly well known, like credit scoring. So, people have been applying for credit for a very long time, and the banks need to evaluate the risk associated to the credit application. But the same idea can be used in other contexts. So on Kiva, for instance, which is this platform that allows to fund projects in developing countries, to also predict if the amount of risk related to those loan applications, and so very useful. There is this example that I like very much, and I'm going to use it in the rest of this presentation, which is real estate. It's fairly simple. You've got a real estate property on the market, and the seller gives an asking price, and but maybe that's not the real value of the house. What would be interesting to know would be, based on all the data and all the previous real estate transactions that have been seen, what is the right price? What is the right value for this property? Which is what this website does, so Zillow in the US. And they've got this thing called the Zestimate. Fade that again. Right, it's here, yeah. Zestimate, it tells you, in this case, it's pretty similar to the asking price. Right. And the problem associated to that is a regression one. You try to predict the price. So imagine that, all right, in this data, each row is a real estate property. Each column is an aspect of this property. What you try to predict is the price column. So that's what machine learning does. It fills in these missing values. And this is the general idea, training a model and then predicting with a model. How do you do that? Well, it's a big topic. There's challenges around that, Kaggle challenges. But now there's products that automate this. And actually the people at, so DataRobot, for instance, is one of these products. They've hired tons of, a few Kaggle experts to implement this, automating this process. So you don't really have to worry about that too much anymore. At least that's the promise. BigML is another example. They do this automatic optimization thing. So, automating the creation of machine learning models. And I tried it out on the Kaggle challenge. It wasn't that great, but still, fairly good. Like, out of 625 human competitors, data scientists, the rank was approximately 300 and something, so about in the middle. So fairly interesting, and there's the same thing in the open source world based on research, and this is an active research topic, automatically creating the right models given a data set. But it's not just, fancy machine learning products and then research projects. There's also, major companies that want to do automated machine learning, or that do machine learning, automated machine learning in production. I'm taking two examples because we've got a speaker from Airbnb, that's one. And the other one is Salesforce. And we had a talk from someone at Salesforce a couple of years ago, I think, and what that person was saying is that they have more models to deploy than there are data scientists in the world. And in those cases, the only solution is to automate part of the job of the data scientist. All right, I like this comparison of thinking of machine learning as a car. And I think that I had a similar slide last year. But yeah, the researcher would be the person who tweaks the engine. The Kaggler would be the person that puts different pieces together and pimp my model, and then that should be you, I think. So just you shouldn't be worrying about attaching a steering wheel to your engine and attaching wheels and creating the gearbox and so on. You should just use the machine learning product of the car to complete your mission, right? That's what you should be worrying about. So, and that goes back to what someone else was saying, which is that predictive modeling is important, but it disappears into the plumbing. And that person was Jeremy Howard, fairly known in the machine learning community. I think I also had this slide last year, but I've just changed it. So it says, your machine learning system, you have a pile of linear algebra, and I just replaced that with automated machine learning stuff. And what if the answers are wrong? Well, it's important to know how to evaluate that, how to quantify that. So maybe predictive modeling is disappearing, in the plumbing, but model evaluation is not. And that's probably one of the first things you should worry about before starting any implementation. Once you've specified your machine learning task, classification, regression, and so on, you should be thinking about that very early. And because depending on what you choose, certain models, so each line is a model, might be better, and each column is a way to evaluate the performance of the model. So green means good. So depending on what's the right way to evaluate the performance, you would choose completely different models, right? So it's very important to think about that as soon as possible. Otherwise, you can't really optimize things. And again, going back to the Uber example that was presented last year, there was this view of the interface. So for them, it's also important to show these views, these graphical views of the performance metrics, not just to engineers, but also to decision makers. Right? So yeah, decision makers need to worry about that. They are, going back to Kaggle, so there's something that they do in addition to the machine learning competitions, is these surveys every year. And there was one on what are the barriers to using machine learning in production in your own applications. And so they identified, so they did this survey and had tons of people reply to the question. A lot of people are saying that, all right, we are not really getting value from machine learning because there's a lack of a clear question to answer. Results are not used by decision makers, so it's important to involve decision makers as early as possible in your experimentations with machine learning. And you see that the machine learning canvas is a good tool for that, to have everyone on the same page. Lack of domain expert input. You also want to have your engineers and scientists communicate with domain experts as early as possible. Another thing that the machine learning canvas will help with. And then integrating findings into decisions. And that's probably one of the first questions that the machine learning canvas asks you to answer. What do you want to do with the predictions coming out of the machine learning model? And I like to tell people, all right, you specified your machine learning problem. The first thing that we naturally want to do is to do a proof of concept, or to see if it works. Is it feasible? Do we get good results, and so on? But before doing that, I like to ask people, all right, imagine that you would get perfect predictions. How do you use them? How do you make something useful? Sometimes it can be straightforward. Other times it can be very difficult. And even if you have perfect predictions, there are cases where the system is still useless. So it's very important to ask yourself those questions as early as possible. And I think that this rings very true in the domain of machine learning. So we saw that one of the barriers is the formulation of the problem. I think that the full quote from Einstein was, the formulation of the problem is often more essential than its solution, which may be merely a matter of mathematical or experimental. Sorry, I don't get the. Well, it may be it involves math and experimentation, but yeah, formalizing the problem is the most important thing, right? Sorry, I couldn't get the right quote, but anyways, machine learning canvas. The idea of the canvas, and you might have heard of other types of canvases like the business model canvas or whatever. This is not really connected. I mean, there might be some similarities, but the idea of a canvas is just to represent things in space in a way that makes sense, so that instead of having a long document, a long Word file, you would have, a visual chart that would make it easier to navigate in, a certain amount of information about machine learning systems. So the idea is to describe machine learning systems or AI systems, and specifically, we don't want to describe everything about them. We want to describe the learning bits. So we want to speak about the data that is used to learn from. We want to speak about how predictions are used, and in the end, how can we make sure? How do we know if the whole thing works or not? This is what the machine learning canvas focuses on. This is what it allows you to think about. There's quite a few. So this is the visual chart. Things that are next to each other should be related. Like you see that data sources is right next to collecting data. All right, the data stuff is over there. And there is a structure to this document, which is the following one. So starting at the very center with the goal, what you're trying to do, why you want to do it, and who do you want to do it for, I think that it's very important to also think about the who, because there's always someone, there's always a user of your system. There's always an end user. And many times discussions that you have about machine learning applications don't really go forward because it's not clear who the user is, who the value proposition is for. So, identify that first. And then maybe you can start thinking about, all right, how do I translate this value proposition into a machine learning problem? Probably be best to limit yourself to classification and regression at first. There's already tons of things to be done in classification and regression. So which one do you want to do? And how do you translate this value proposition into a machine learning question, which is a classification or regression problem? Like in the case of real estate, it would be how much is this property worth? And then you'd expect a number as the answer. So maybe it's fairly easy in the real estate example, but there could be other examples where this is very difficult to translate it into a machine learning task, to translate the value proposition into a machine learning task. So anyways, this bit is about predictions, right? You have this goal. How do you reach this goal? Well, with predictions and also with learning from data. And finally, you would also say something about how well you are completing your objective, you're reaching your goal. So this is the evaluation part, the live evaluation. All right, I'm going to describe each of these boxes, but starting with those ones. This is more like the sort of background information. Things to start with would be at the top, and then as soon as you've done the top bit, I think you should do the evaluation. Think about how you can measure whether or not you are providing the value that you proposed. And then afterwards, you can go into the specifics, which are grayed out here. So let's start with value proposition. And again, we're in this real estate example. So one idea, what could we do with these predictions? One idea I had, and I think that's sort of similar to what Paul Peterson presented last year at PAPIs in São Paulo. You could use those predictions to make better real estate investments. And how would you do that? You'd compare the price predictions with the asking price. So if you're predicting that the value is higher than what the asking price is, might be a good deal, right? Because maybe the property is undervaluated. And yeah, that way you find the best deals. All right, let's keep it at that for now. Data sources, you'd need to collect data. Maybe you would want to scrape data from, I don't know, Zillow, or the example that Paul had was Redfin, I think, which makes it, I think they have a feature to export data in a very convenient way. And then maybe you also want to use, open data, like data about public transports or schools. Some of it is open data. So, that's an external data source. You'd probably want to, make it even more specific. Maybe not right now, but as you revisit the canvas, make it more specific. Say, how do you get that data? Is it an Excel file or is it from an API? So, making that a little bit more explicit. And maybe you also want to, right, so Redfin would give you an address of the property, but you wouldn't know where it is on a map. So maybe Google Maps allows you to do that. You could list it as a potential data source. Right, so just identifying that and maybe some of the constraints related to accessing those data sources. And then, all right, so this is just data sources, but you need to have a data collection process, right? And most often we think about collecting an initial data set, but you should be thinking about the long term, like always keep collecting data because things change and you want to capture the changes in the environment. So maybe what you would do is that every week you would collect, new data for the new properties on the market, right? There's new properties on the market all the time. So you'd get the characteristics. You wouldn't know the price of the transaction. The property has just arrived on the market, but you would know the asking price. And you would also look at all the sale records from the last week, where you'd see properties that you've already seen before, but this time you would get the sale price because these are sale records. Right, so that's what we do every week, and maybe initially when you create your first data sets, you would use the past year's data. Maybe it's just maybe you want to do 2 years worth of data, maybe 3 years, but probably 10 years is a better idea because you get data which is too old. So that would be informed by domain knowledge. So it's useful to, when you're doing this, to get the domain people involved, because they will tell you what makes sense and what doesn't, right? So in that case, past year should be good. All right, so going to the left of the canvas, what is the machine learning task? So we could say, all right, regression task, how much is this property worth? Expecting a number. So the input is a real estate property. I'm not saying anything about how to represent this property, right? You may be thinking about looking at the number of bedrooms or the surface or these things. Let's not have this discussion too early. Let's just identify what is the object behind that. Right? What is the input object? So we want to predict the value of this thing. It's a regression task. But you could also think of things in a different way. Like you would still get... so another way to do this is to say, all right, I still have a property as input, but my question is this a good deal? Right? You have a property, you have the asking price, and you need to say, yes, it's a good deal, or no, it's not a good deal. And this is very valid. I haven't seen anyone do that, but on paper, it's valid. So it's a possibility. And there's quite a few cases where you could do either regression or classification. So one, at least real example, is predictive maintenance. You could either predict how many days until your equipment fails, or you could predict whether there's going to be a failure within X days, which is classification. So yeah, there could be different answers to these questions in these boxes. Okay, so we've identified a machine learning problem, but then we still need to make the connection back to the value proposition. So how do you use predictions in order to make decisions to do things that change the world, right? What you would do is that every week you would compute predictions for the new properties that have just come up on the market. And what you can do then is filter out all the bad deals, which are those where the asking price is higher than what you predicted the value was. And then quite simply, you could just give that to the real estate investor who's in charge of visiting the properties and deciding what to invest in. So it goes back to what Fabio was saying regarding augmenting people. And probably what they do is that if they visit the property for real, they've prioritized which properties to visit first. And once they visit, they make sure that everything looks okay. And if everything looks okay, they can invest. They can buy the property at the asking price, or maybe they can negotiate. But yeah, that would be the assumption. How do we make sure that this thing works? This whole idea will work well. Well, first thing first, if you want to improve investment decisions, your investment return should go up. You would also think that by prioritizing the list of properties to visit, you would decrease the time spent visiting properties, because you're not going to waste time visiting properties that are not good deals, right? And you could also just look at the accuracy of your predictions, right? So maybe what you do is that instead of considering all of the properties on the market as potential properties where you could invest, you're going to select randomly half of them and not do anything about them. That's what you call the holdout set. And then on those properties that you didn't act on, you can compare, when they finally get sold, you can compare the selling price to your prediction and see if your model was good or not. Right. So again, I'm going to make this presentation a little bit shorter than intended. So I'm not going to speak much about the other boxes, but here you've got, just say a few things. You've got a few things about making predictions, when you want to make them, and how much time you have to make predictions, any time constraints, any technical constraints on the predictive engine that makes predictions, and also on the engine that builds models, right? How much time do you have to update your model, and how often do you want to update your model, those things. Features, so how do you represent your input? So that's also in the learn bit. So characterizing the data that we learn from. And then maybe before you do you deploy something for real and evaluate it and monitor it live, maybe you want to do an offline evaluation where you would sort of simulate what would happen if you would have implemented this. So using the data that you already have, make a simulation and see if it works well or not. So you would explain the simulation in that part of the canvas. So as you can see, we're starting from sort of background information and going down to more specifics, right? Okay, I'm gonna skip that. And right, if you're wondering what my ideas would be for what to put in these boxes for the real estate example, you can find that online. I've shared an example. I've shared a few examples, a few machine learning canvas examples. So there's the real estate one. Right, and another way to look at this canvas, so I said that it's a good tool to get everyone on the same page and to get everyone to think about the same machine learning ideas. So this is sort of how I think people would, depending on your role, there might be boxes where you should be more involved. So the data scientist would be more involved in the specifying the machine learning task and the features, and how often to build models, and maybe the software engineer should also be involved in determining the technical constraints for building models and also for making predictions. Right? So yeah, the idea is to have everyone work together on making these canvases. So that's what I do in workshops around the machine learning canvas. And another key ingredient is this for creativity. Have some drinks. But it's good to be creative, right, in this process. Right? There's nothing wrong. You just have to iterate and be creative and share your ideas and discuss with your team members using this tool. So my recommendation, just to wrap up, would be to frame your machine learning problem before implementing anything or before hiring anyone. And then, once you have a better idea of what you want to do, you can think about implementation. I'd like to also leave you with a quote from an interesting article on also, using machine learning in real-world projects, where essentially the author was saying that product people should be focusing on solving problems, solving real problems, but I don't know, for some reason when we think about machine learning, so we forget about the engineering aspect, but we also forget about solving real problems that people have. So think about that. You're thinking about your end user of your predictive system. Think about what are their pains and what are their problems before you do any implementation. And sorry, the author is Chris Butler. That's it. You can find more information about me, or you can get in touch with me at louis.ai, and also there's links to more resources about the machine learning canvas and other things if you want to learn things about machine learning. But also there's machinelearningcanvas.com, which currently redirects to the other website, but it's going to be separate at some point. And all right, that's it. Thank you. Yeah, we're a little bit late, but I can take 1 or 2 questions, and then I'll be around in the coffee break if you want to speak with me. And the questions have to be in English, right? Not Portuguese.
Hi, Louis. This is Carmelo here. You mentioned a couple of tools for automated machine learning. Do you have an opinion about H2O.ai, which is one of those?
I haven't tried H2O, but my understanding, I've just looked at what people said about it and the product description. It seems to be fairly similar to what DataRobot does.
Yeah.
I think that what's also interesting to look at in these tools is not just, the first thing that comes to mind is, all right, I'm going to try this one, this automated tool, and this other one, and benchmark them and see which one gives me the best performance. Yeah, that's interesting, but also, looking at all the other stuff, like one of the things that Fabio was talking about is explaining predictions and the transparency. And so some of these tools give you more insights into, how the model is behaving. so that it doesn't look like a black box. So also look at these things, the visualizations of models and their performance, to get a better idea of what would be right in your specific case.
Okay, thanks.
All right, just one more question, and then we can speak more in the coffee break.
Is it considerable to build this kind of project and use the ML Canvas to redirect projects that deals with feature engineering specifically, not the modeling? Because I've seen some features that they were so complex to generate, they were actually models that would generate features to feed other models. So should the canvas wrap the whole thing, the final model?
What you could do is you could chain canvases where the output of one machine learning problem would be fed to another machine learning problem. So you would have a canvas for each machine learning problem, and you could sort of chain things. But the other thing that I want to say about feature engineering is that, yes, this is this is a discussion that needs to involve everyone, domain experts, but also engineers, maybe data scientists, to make sure that the ideas are sane, but also engineers, because you have constraints in terms of, so I was saying things about the time that you have to update your models or to make predictions. That also includes the time to generate features. So, your ideas in terms of features, they must be feasible also given the constraints that are listed in the other boxes of the canvas. So I would definitely recommend, even if, the main concern is feature engineering, I would recommend to fill in the whole of the canvas, because also one thing that we observe in machine learning projects is that changing anything changes everything. So everything is connected. So it's good to make the effort of specifying the whole problem, not just the feature engineering bit. All right. So again, let's speak more in the coffee break. And yeah, thank you again.